And welcome to this short little video, and in this video we're going to be looking at the concept of voltage dividers, and as a consequence of that we're also going to be looking at the light dependent resistor. To start with then, we'll have a look at what a voltage divider actually is, and here we've got one, and you can see it consists of two resistors in series, and they're given a supply voltage, which in this case is 10 volts, and the second resistor is attached to the 0 volt rail. Down here there's an equation, and it says V out equals V in times R2 over R1 plus R2. And what that equation is actually measuring is V out, which is the voltage at this node here where the two resistors join together. V in, of course, is the supply voltage, in this case 10 volts. R2 is taken to mean this one here, facing the 0 volts rail, and R1 is taken to mean this one here, facing the positive rail. Well, let's work through the equation and see what we've got. Well, we've got V out equal to V in times R2 over R1 plus R2, so the first thing we've got to do is we've got to get this bit into numbers. Now R2 is equal to 1 kilo, and so is R1. So we'd have 1000 over 1000 plus 1000, which is of course 2000. So we've got 1000 over 2000. If we cancel all the zeros out and boil it down to its lowest terms, what we've actually got is 1 over 2, and 1 over 2, as you know, is a half. So V out equals V in times a half. V in is 10 volts, V in times a half is 5 volts, and that is the voltage we would see coming out of this node here. It isn't quite as simple as this in realistic terms, because what we would do is we would feed the load here and we would cause an imbalance. So if we had another 1k down there, the total resistance would be the parallel resistance, 1k, 1k, and we'd have to recalculate. But for this purpose it's good enough. So we know now that if we've got two fixed resistors, we'll get a constant voltage out of there, and that if the two fixed resistors are of the same value, what we'll get is half the value of the input voltage appearing there. The trick we can do is that we can put a variable resistor on the bottom, or indeed on the top. If we put a variable resistor in there, what we'll end up with is a fixed resistance, a variable resistance, and a change in this part of the equation. If we have a change in this part of the equation, we'll have a change in the voltage appearing at this node. And to illustrate that, what I'm going to do is I'm going to pan the camera a little bit and come down to this very simple circuit. Very simple in the sense that it's got very few components in it. Let's zoom in and see what we have got. Well, we have our fixed resistor, which is this one, and that's 100 kilo. Sticking up here on legs, we have a light dependent resistor. This is of course a 5mm LED, and what it's doing is it's going to indicate what's happening when we do various things with the voltage divider we've constructed here. And this resistor of course is stopping the LED from gulping too much current and blowing itself up, and then going back to the negative supply rail. Well, the LED is shining brightly now because it is 20 to 11 at night, and it's very dark outside and I'm working under electric light. What happens if I put a light source directly on to the light dependent resistor? Well, let's see. and we should see that the LED has gone out. If I shield the LDR from the light source, there we are, we'll see that the LED lights again. If I can get this fine enough, there we are, we can see the LED starting to glow, going off, depending on where the shadow is. And that, of course, is as a result of what's coming out of this junction, or the node of the voltage divider. Well, I think what we could probably do now is put a multimeter on there and see what we get. Well, what we have here is this multimeter is reading, with reference to ground, which is here, the output voltage at the junction here. I'm quite sure how clearly you can see it on the camera. Looks alright in the viewfinder, but it says 2.36 volts. Well, it's flickering between 2.36 and 2.37. What I'm going to do now is I'm going to shine a light onto the LDR, and we'll see what happens. Well, straight away we can see that the LED has gone out as the light approaches. And it's not surprising, because if we look at the multimeter, as the light approaches, the voltage is dropping. And the nearer I get the light, the further the voltage drops. And if I get it at its most intense, the voltage has now dropped to 0.15 according to the multimeter. Take it away again, slowly, and if you can see the multimeter there quite clearly, you'll see that the further away I take this light, the more the multimeter goes up, and the more output voltage we're getting from the node of the voltage divider. And there we are. And what we've actually made there is a dark activated sensor. Goes dark, puts out more voltage. There we are. What would happen if we swapped the positions of the resistors around? Now, at the moment, the fixed resistor is facing the positive rail, and the light dependent resistor is facing the negative rail, so it's rather like this one, and this would be the fixed resistor and this would be the light dependent resistor. So let's swap them round and see what happens. But due to the electric light, the LED is still on and we're still getting 2.64 volts. What I'm going to do this time is I'm going to shine a light on to the LDR and see what happens. And you see that this time the voltage goes up dramatically and the LED glows a bit more fiercely. What happens if I shield it from the light and make it darker? Well, this time the voltage goes down and the LED goes out. And what we've made there is a light activated sensor. So merely by swapping around which way the components go and making one R1 and one R2 or vice versa, we can make the circuit activate on light or activate on dark conditions. Well, this is a thing that's been doing the work in varying the voltage, and it is of course a light dependent resistor, or sometimes it's called a photoresistor, or an LDR, or I've even heard the term photoconductive cell, but not very often. It's a variable resistor, and they do vary in construction. As I said, I've measured this one up to 3 megohms, but it's probably got a lot more in total darkness. Usually you'll find that they'll go from tens of ohms to several megohms, and they can vary even within the same batch. Now they're made with a semiconductor base, but there's cadmium sulfate in there as well for a doping. So they're not really nice things, and they are made of quite hazardous substances. This is the giveaway that it's a light dependent resistor, and you can probably see that in the camera. If I move the light a little bit more, there we are, you can see the pattern on the top. The swirly line there tells us that this is a light dependent resistor. I move this yellow wire, you can see where the junction was, just there, for the voltage divider, and of course the light dependent resistor here is in the positive rail of the power supply, and the fixed resistor is in the negative rail of the power supply, and that is what was working the LED.